Hello, welcome to another episode of Chemistry is Easy with Mr. Jesse. For this tutorial, our objective is to name cycloalkenes. Naming cycloalkenes is very similar to how cycloalkanes are being named, except that the double bond carbons are assigned as number 1 and number 2, and number 1 is assigned to the carbon that is nearest to the substituent. So let's take a look at this example over here. First example, we have a cycloalkene that is composed of 1, 2, 3, 4, and 5 carbons. So it's a cycloalkene because we could see here a double bond. Right, so if it was just a cycloalkane, we will call it cyclopentane. But since it is now a cycloalkene, we will call it cyclopentene. Moving on to the second example over here, we have a cyclopentene. However, on this cyclopentene, we have an alkyl group, no, a substituent rather, which is a chloro. Now, according to the last sentence of the exception, number 1 is assigned to the carbon that is nearest to the substituent. So since our substituent is chloro and it's attached to this carbon here, therefore this tells us that carbon 1 should be associated, or not, this should be our carbon 1, whereas, which means that this should be our carbon 2, carbon 3, 4, and 5. So to name this second example, we will have 1-chlorocyclopentene. So 1 because the chloro is attached to carbon 1, and we have cyclopentene since we have a cycloalkene composed of 5 carbons. Name this cycloalkene. So this cycloalkene is composed of 1, 2, 3, 4, 5, 6 carbons. So we will have a cyclohexene. Now on this cyclohexene, we have here a constituent that is attached to one of the carbons of our cyclohexene, and this constituent or alkyl group is called a methyl. CH3 is methyl. Now let's see. Based on how we numbered our carbons, we will have 6 methyl cyclohexene. 6-methyl cyclohexene. But recall on the previous slide that we should be able to assign the number to our carbons in such a manner that carbon 1 is closest to the substituent. So if we have here, if we assign it like this, the substituent is assigned to carbon 6. However, if we would number our carbons in this manner, so that we start from here, 1, 2, 3, 4, 5, and 6, then we will have 3-methyl cyclohexene. So which of these two names are actually correct? Alright, so based on the law, the second name, which is 3-methyl cyclohexene, is actually the most appropriate, since we have to make sure that the number that is assigned to a methyl group should be the lowest. So this is lower. Now here's another example. Name this cycloalkene. So this cycloalkene is composed of 5 carbons. So we have 1, 2, 3, 4, and 5. So we should have a cyclopentene. Alright. Now on this cyclopentene, we have substituents attached. We have a methyl here. This is a methyl, and we also have another methyl attached to one of the carbons in our cyclopentene. pentene. Now we have to assign the numbers to these methyl group, and as much as possible the numbers that we assign to each of these methyl groups should be the slowest. So taking this manner of numbering the carbons, we will call this 1, 5 dimethyl cyclopentene. So that would be 1, 5 because in carbon 1 and in carbon 5, that's where our methyls are connected, and di, which means we have two methyls being connected to our cyclopentene. All right. Now, however, if we are going to number the carbon atoms in this manner, so that we start here with 1, this is 2, this is 3, 4, and 5, we will be able to come up with another name, which is 2, 3 dash dimethyl cyclopentene. So the 2 and 3 here means that on carbon 2, we can find our first methyl substituent, and on carbon 3, we can find our second methyl substituent. And again, we have the di, which means that we have two methyls being connected to our cycloalkene. Now, recall that the lowest possible number should be assigned to our alkyl groups, and therefore that means that the second name is more appropriate. So you could also try adding 5 and 1 and 5, which would give you a 6, and 2 and 3 would only give you a 5. So the lowest possible numbers that we could assign to our methyl groups would be 2 and 3, and therefore this is the proper name of this particular cycloalkene. And here is our last example. Name this cycloalkene. So again, we start by numbering the carbon atoms that composes this cycloalkene. So we have 1, 2, 3, 4, 5, and 6. So we will have a cyclohexene. Now, for the previous examples, we only have one bond, but in this time we actually have two double bonds present. So we have this double bond here and another double bond on the other side. So how do we name this one? Then we have to determine the location of the first double bond. So numbering it this way, we will have 1, comma, so, and then the other one would be 4. So 1, 4, cyclo, then we say hexa, diene. This means that we have two double bonds existing in our alkene. So this is the same process as how we name if it was not a cycloalkene. So just a straight chain. So di again means, or diene again means that we have two double bonds, and these double bonds can actually be found in carbon 1 and in carbon 4. Now, will we have the same name if we start counting somewhere else? So for example, if we start counting here, 1, 2, 3, 4, 5, 6. So still we will have 1, 4 cyclohexadiene. Also, if we start counting here, we could start counting here 1, 2, 3, 4, 5, 6. We still have 1, 4 cyclohexadiene. So as a matter of fact, the name of this cycloalkene is 1, 4 cyclohexadiene. And that concludes our tutorial on naming cycloalkanes. Always remember, chemistry is easy with Mr. Jesse.